Carim Popa on comparing spooffax and X-text for editor support in Adobe.
Hello everybody. Before introducing you to the problem I was trying to solve, I would like you to give some context. Well, imagine you are working as an engineer at a manufacturing company and you have to manage some workflows. Luckily for you, there exists domain-specific languages. They allow you to specify these problems with the domain-related terms, which is great. To implement the implementation of domain-specific languages is very costly and it takes a lot of time. For that purpose, language workbenches were introduced. They significantly reduce the implementation time of domain-specific languages by automatic generation of artifacts for the domain-specific languages. This leads us to the problem we have. It's a workbench selection. There are a lot of workbenches out there, and sometimes for the developer it might be not that trivial to choose which one might be more suitable for his needs. It is even worse since there is not that many research compared to the research done in that field. So my goal was to address this gap by implementing a domain-specific language using two workbenches called Xtext and spooffax, and focus on editor support features since these affect usability. The choice of these exact workbenches is motivated by their maturity. They still get frequent updates and they have pretty extensive documentation available online. Here's my research question, which I was trying to address. Essentially, we're trying to see how spooffax and Eclipse Xtext compare in the way they allow implementation of editor support features. We answered this question by first qualitatively comparing the implementation approach. Second is by comparing the behavior of features and seeing how many attempts it will take to actually implement them. And third is to do a quantitative comparison of effort, time, and lines of code. First, I'd like you to show the DSL which I implemented. It's called Dot. It's a subset of Dot, which is a graph description language. Here's an example of a program written in this domain-specific language. It describes a graph, which you can see here. Yeah, there are a bunch of node declarations and also nested subgraph. You can see here that generated a nice graph. Well, there might be some problems, like for example here. You don't want to have an attribute compound to be defined on the edge. That's also an error reporting, which I implemented. And there's also another problem which mostly concerns the value that you're trying to assign to the compound attribute. Then there's also a nice thing called code completion. It basically assists developer with the code completion suggestion, which would make sense with this program. Well, here's the methodology. We essentially tested our reporting, semantic code completion, also name resolution. We also measured the development time for a feature, lines of code, and the number of failed attempts. The discussion on this will be further. First, let's talk about the implementation approach. In this table, we're trying to summarize the main differences between the workbenches across these points. First, organization-wise, spooffax requires you to manage 3 different meta languages to implement the DSL. It's called SDF3, Stratego, and Statics. While Xtext, it's much more simpler. You just need it's centered around EBNF grammar definition, which allows Xtext to generate necessary artifacts and EMF model. Then semantic specification is also a point where they are different. Essentially, in SpoofX you use the declarative meta-language Stratego, while in Xtext you're writing the semantic specification imperatively using Java. Also, context handling is quite important since for semantic checks it is necessary to know the elements surrounding structure to impose specific constraints. While in SpoofX, you can't get this context information out of nodes. It's not available. That leads you to write explicit traversal code for nested terms. So you would need to pass the context information from all the way from up all the way down. While in Xtext it's conveniently available through EMF container relation. Also, I forgot to mention EMF. You can imagine this as a class diagram of the grammar of the language, essentially. And yeah, also in SpoofX you have extra configuration step to actually enable the editor support features. Next, I would like you to show some code snippets for our report for each of the IDE features I implemented. Here is the our reporting for SpoofX and Xtext. Here in SpoofX, it's essentially done through the rules, which are pattern matched against the AST nodes. Then certain constraints are checked against those nodes, and if those constraints are violated, then a meaningful error message is attached to that AST node. While in Xtext, you just simply define your custom validator class with check annotated methods which include all the logic related to generating the error messages and checking whether constraints are failing. Also, for code completion, in SpoofX, you need to essentially the rules are traversing the whole AST, looking for the holes. These holes are pattern matched against placeholders, and then when the placeholders are found, certain proposals are suggested. While in Xtext, since code assist, syntactic code assist is already provided by the Xtext, we had only to override a certain method from that code assist, which was called complete keyword. And then let's move to name analysis. Well, in Xtext, no code was actually needed because it was provided out of the box by Xtext. This was allowed by cross-references in the grammar definition of the language. Then, while in SpoofX, to do that, we still had to build the lookup table using the dynamic rules. Yeah, we would build that lookup table, and then this lookup table will be used to actually find the definition side of the of certain nodes. And here you can see the nice graph of amount of failures it took me to actually implement certain features. It is clear that for SpoofX, it took at least one attempt to implement each of the features, while in Xtext, most of the features were implemented immediately, apart from the code completion. The reason why it took that many attempts for SpoofX is mainly because of the configuration issues and also some logic-related issues in the Xtext, in Stratego code. Okay, now it's time to compare the effort. Here you can see the graph which describes the time spent on implementing each feature, and well, you can clearly see that SpoofX took considerably much more time to implement each of the features, where it was also a decreasing trend since the more features we were implementing, the more comfortable we were becoming with the language itself. Also, the reason why it took so less time for Xtext is mainly due to the fact I'm familiar with Java. I have experience with that language. Next, I would like to show you the difference in lines of code. Essentially, here we have an opposite trend. Xtext shows that we have more lines of code for error reporting and code completion. That's due to the fact that Stratego is more declarative, and as you could see in the previous slides with the code snippets I was showing to you, certain methods were much shorter than the ones written in Java. Yeah, because in Java you need to actually write these steps to reach the intended behavior. Yeah, and Spookfox also required rules for name resolution. You might wonder why we have 3 hours for name resolution here. That was mostly due to the fact that I still invested time to actually learn why it was provided out of the box. So I decided to include that. Yeah. Right. Let's go to the conclusions. Want to choose which? So, if you care about code elegance in your code base and conciseness matters, well, I would suggest going with Spoofx because, well, the amount of lines of code was lower, the code was more elegant. If time is a big constraint in your project, then probably choose Xtext. Then, if you have time to invest learning Stratego, go for it because it might pay off in the future. Well, as I said before, the fact that it was the first time me interacting with Stratego affected the results. So don't take that as a ground truth. And Xtext might be a good choice if you are already experienced with Java. And last, yeah, DSL has complex semantic constraint, choose Spoofx. Or if you have a really simple name resolution in your DSL, yeah, Xtext can also be a good option. Yeah, that's it from my side.
Questions? Yeah.
So you're saying your experience with Java has a lot of impact on the time it took you to implement features in Xtext. Do you still think this time it took you is like valid results that you can use to prove like a point on how long Xtext takes? Or is it more if someone has your experience that Xtext is easier to learn?
That's a good question. Actually, I was thinking about that. I do think that it might be a good potential for future work to actually compare that with a person who has no experience both in Xtext in Java and Stratego to actually measure objectively how this how the familiarity with the tool affects the difference in result.
Would you expect a certain difference? So, just speculation, but would you expect one to still be quicker than the other?
I would also like to point out that there was, since Xtext had a really good a book where certain things were explained in much greater details than in the paper I was reading for Spoofx, it was much easier for me to write certain things in Java for to implement these editor features. So I believe that, well, if you already have a clear idea for how to implement stuff, probably Java would still take less time to achieve the goal.
Vadim?
Thank you. One of the thing is that it's nice to have this comparison, but you were one person and you had a limited a linear timeline, right? So which one did you do first? Which did you do second? And in how much did that potentially influence your learning curve in whatever was the second?
Yeah, that's a good question. First, I started with spoofers. In the beginning, I was planning to to eliminate this learning effect by first implementing certain feature in the spoofx, then xtext, and then the second feature starting in xtext and then doing it in spoofx. I did that for code completion and reporting while name resolution. Yeah, I was
in the design of the experiment. Okay. And the second one relates to your remark that you just made that if your thing is complex, then if you can afford to invest in Stratega, this might pay off later. Obviously, that requires some complexity. Right? So, do you think that complexity will at some point hit when you're staying in dot? Or does it require fundamentally more complex DSLs that you do?
I think it requires more complex DSLs. Complex DSLs because I will try to challenge myself with actually thinking about more complex semantic constraints, but since that is relatively simple, I really cannot think. Even with the name resolution, I will try to think about more complex scoping rules such that I would still need to write something for that. Well, so I believe more complex DSL would be good.
One last question.
So you focused on the developers of
Yes.
these languages. As far as I know, they're both Eclipse based. So was there any difference in the end user would see in the editor they would receive from these languages?
Do you mean the outlook of the editor?
No, I mean like the experience, like the code completion, do they all act in the same way?
I think the editor generated by xtext would be more user friendly. Since in spoofx I was struggling with actually placing the placeholders for code completion, and I couldn't figure out why that was the case. Like, I couldn't find any information about that. While in xtext, it was very intuitive from the beginning. So do xtext. So that's about it.
Okay, let's thank the speaker again.